errors, alpha level, power, all these things. This is what this diagram right here. I would make sure I have it easily accessible on your formula sheet somewhere. One, we need to remember that your alpha level is the probability of a type 1 error. Okay, so the probability of type 1 is your alpha level. Now, most of the time we use 5% or 10% for our alpha level, for our significance level. That's another word for alpha level. Guys, the researcher sets that based on whatever the probability of a type 1 error is. If a type 1 error is severe, then you're going to want a really low alpha level, 1% or 0.5%. If a type 1 error isn't that bad, then you probably have a higher alpha level, like 10%. But you get to decide that as the researcher. Okay. Then we have type 2 error, and the probability of a type 2 error is called beta. Okay, so probability of a type 2 error is beta. And so type 2 error is when you don't reject and it turns out that that null hypothesis was false. And then we get to power. The power of your test is when you reject and that was the right choice because the null hypothesis was incorrect. That the null hypothesis isn't the center, that your center is actually at some other value. That's power. And just to remind us, 1 minus beta is how you calculate power. If you're unsure about these things, make sure you go back and watch the video on my YouTube channel about errors and powers, okay? It's not that long. Just spend some time rewatching that video. All right, the next thing we're going to get into is how to know which inference to run, okay? So going back to the start, you have to determine, well, are you working with proportions or are you working with means? Then once you have that figured out, so you realize you're working with p's or p hats, you have to say, well, how many samples do I have? How many groups are there? Do I just have one sample? Then I'm doing a 1 prop z test. If I have 2, then I'm doing a 2 prop z test. Means can be a little bit more complicated. We'll elaborate on that. So with means, you need to see if you have 1 sample, but be careful because it might look like you have 2 samples, but the 2 samples are paired. Or you've got 2 mean tests, and that would mean that the 2 samples you have are independent, meaning they're not paired. So let's break that down. So look at this difference here. We have a completely randomized experiment. That means we have independence between 2 groups. In a completely randomized experiment, we've got independence between these groups. So I would want to look at the mean of the Pac-Man scores with sound and compare that to the mean of the Pac-Man scores without sound. And I would do a 2 mean t-test. Over here, I've got a matched pairs experiment where I've got every single person here is going to play the game with sound and going to play the game without sound. That means I need to make another column over here that would represent the difference between these scores. So I'm going to find the difference between all of these scores. I'm going to make a new column of data, and this becomes my 1 sample. I get my 1 X bar for the difference between this paired data. These 2 groups are not independent of each other. Okay, so really what happens with this type of paired grouping is that it takes something that looks like it's got 2 samples and turns it into 1 sample. And you can see this breakdown here between what happens if you have independent groups versus pair groups and how your values change. Your parameter is different, your statistic is different. Okay, it still comes from 2 sets of data, but 1 is independent and 1 is paired. All right, I hope this was a good overview for you. Remember, on my YouTube channels, I have videos that look at this content a little bit more in depth. Let me know if you have any questions.